time are we?
Straight at 1 o'clock.
All right, let's wait 5 minutes. I don't know who else is going to show up. The title of this seminar was supposed to be the Martin Birdbeak Neck and other sundry Martin oddities and things. But it's, it's labeled machining a two-piece neck, which can be a little bit deceptive. So I don't know if you guys are all in here to learn about bird beaks. The first part of what I'm going to do is I'll talk about the bird beak, which is a very specific piece of very tricky joinery that Martin did up until 1915. And the necks were made out of Spanish cedar. And then in 1915 they switched to one-piece necks made out of Hungarian mahogany. David can probably talk to why that occurred, or maybe nobody knows. It was they came up with a good supplier. They got tired of doing these joints. The guy who did it for 50 years quit, or retired. It could be a bunch of that
It
stuff.
does correspond with some of the models transitioning to steel string. 1916 was the first year of the Ditson guitars, the wide-waisted guitars.
Yeah.
And even though they were fan-braced, very stoutly fan-braced, most of the people who studied them have asserted that they were designed for steel string.
Right.
So that
But
dedicated
this joint
steel
is-
string guitar.
Yeah, but this joint is stronger than a one-piece, so
Right.
maybe they just thought, okay, we're making some changes here.
It was also the
part of
point at
that.
which their production really jumped.
Yeah.
It started going from 300 guitars a year, all through 1890 through the teens, to thousands a year. By the
Yeah.
early 20s, they were making 4 or 5 times as many guitars. So
Yeah.
it might have corresponded with that too.
Yeah. Would
So-
you love to find an old ukulele with a bird beak joint?
The old mandolins have it. The old mandolins have it.
Yeah.
The old bowl back mandolins
Oh, that's awesome.
had bird beak joints.
I was not aware of that.
Yeah,
That's
take a look at some
crazy.
of those old mandolins.
Yeah.
They have the bird beak joint.
Cool.
It's cool. They're beautiful.
All right, so this is the joint I'm talking about, and this is the head plate that goes with it. And it's diabolically tricky. This is very similar to what Martin was doing, with one exception. The Martin version, this angle is 8 degrees, and on Martin it would have been closer to 30 degrees. It doesn't need to be a wider angle for strength reasons. There's lots of Spanish guitars out there with no angle here. They're just a point, but there's no tapering this way. And it's plenty strong. If you get edge, you've got edge-to-edge glue surface there, and if it's a good joint, you're good. So, that angling that doesn't really need to be there for the strength, but it does make it much more complex, which is why, people who hate themselves like me do it. That thing goes on there and creates the joint. That part gets cut off, obviously, and then a head plate goes on top. This part, you start out with a really chunky blank, and you have to, because the only thing that's left is the last little straight part of the volute on the back that gets carved to a point like a standard Martin dart. And this is why Martin ended up with a dart, because they had this neck joint, and that's the carryover to all the modern style 28 necks and up. So first thing I've got here is mill the blank to 2.35 wide. Oh, you know what we didn't get to do before starting? Bear?
Yeah, well,
Yeah, we got to figure out how to put the pictures up there. Who was going to help me do that? Somebody was here to help me figure that out. Hello, to the rescue. No, I haven't done a thing. I've got a memory stick here. I see you. Okay, let's figure this out. All right, so one nice thing about this is you get really good yield, because you can take, it depends on how you buy your mahogany, you can buy narrower stock. You don't need to buy 12-quarter, because you don't have to get that wide. And you can also, if you buy a slab of mahogany to use, you can sister these guys in here all the way down and get really good yield out of it. It's very easy to do. And so I start with the blank has to be wide enough, just wide enough to accommodate your widest fretboard at the body joint, whatever that might be. I make them wide enough so that you can have a 2 3/8 bridge and a moderately wide neck, or at the nut. So mine start out at 2.350, which is wide enough for a very wide bridge spacing. And I also like a little extra space on my fingerboard. I don't like the strings being too close to the edge, so that gives you plenty of room. And that's what I start out at. If you're going to do one of these, it's a long learning curve, so you might as well crank out a few of them while you're at it. So if you're going to do that, what you need to do is pay very close attention to keeping everything dimensionally identical. You don't have to get demonic about it, but just pay attention. Don't have a bunch of stock that's slightly different sizes, because it's going to throw everything off. And when you start getting down to the nitty-gritty down here, everything has to be just right. So then I'm going to cut the back side to 1.325, 1.30, or 1.275. And the different depths correspond to different head plate thicknesses. I have different head plate thicknesses because I'm doing banjo tuners on some of them, which require a very thin plate. You can't buy banjo tuners that have a long string post. So you either have to inset it into the back of the head plate, or you need to have a thinner head plate. And the early Martins that had friction pegs were quite thin. It's an elegant look, and it's plenty strong because it's not cut at an angle. This is, you've got parallel grain on this thing, so it's plenty strong being thin. And the joint itself is exceptionally strong. So I've got a thin version. I've got a slightly thicker version, which I use for standard Waverly tuners. And then I have a much thicker version for doing slot heads. Now, the depth from this surface to the back is critical, because as you change the thickness of this, that changes where your volute is going to end up. And it also changes this little gap in here between there. So these little changes make things much more complex, which is why it took me over a week to figure this thing out the first time through. And then when Bear asked me to give a demo on this, I accepted, because I needed something to force myself to do it again. So I thought, I'm going to have to learn how to do this again.
That's the best way to do it.
Okay, so we'll do that.
Okay.
All right, thank you so much. So let's go over here. And so here we have the blanks. The picture isn't so good, is it? A little bit washed out. Yeah, let's see if that helps. Nope. Okay. It's a little better.
John, there's a slider over here too.
Oh, okay. Let's try that. Yeah, can we change well, that's the size.
Oh,
Yeah, but opacity? I don't know if that's going to do anything for us or not.
yeah.
Oops.
The trouble is it opens in an editing sort of program.
Yeah. Oh, I got to figure out which side of this guy to use to click on things too. So let's see here. Is that the right one? Nope, that was the wrong one. Okay, let's try that. So there's my neck blanks laid out. And I'm going to double click on that. Okay. All right. So I've got them milled this way. I have them milled on the fretboard surface. At that point, I go ahead and cut a truss rod slot. I'm going to put a graphite bar in this thing. It's not going to have a truss rod, because I want to keep the weight really light, and I want it to feel like a traditional instrument. But that truss rod slot is going to be a registration for other things that I do to the neck. So that's important. You do not need to run it through the bird beak. You can stop it and put a traditional truss rod in there, or a graphite bar that doesn't run all the way through, although I don't know why you wouldn't run it all the way through. And it works just as fine. You just need some way to register this, and that's the easiest way. And I cut mine by running it along a table saw and then flipping it so it's absolutely perfectly dead centered, which is useful. It's not absolutely critical, but it is helpful. So that's just the way I do it. So once I've got that centered, I take this little tool right here, which is, I think these seem slightly out of order, the pictures, but we'll see. This is just a centerline tool that I made just to make it easier when I've got a batch of necks. I did like 15 of them at once. And since I know everything is milled exactly the same, I made all of them oversized for the widest possible blank. Then my center line is established, that way, and I know that they're all going to line up. You have to get a little bit hyper about this stuff because the joint requires that. It's not like a normal neck where if your center line's off a tiny bit, it's fine. You want everything to be pretty good.
John, have you found the graphite? Have you found the graphite truss rods to be inconsistent in their width?
In their width, yes.
Yeah.
Yes, it's maddening.
Yeah.
Yeah.
That's why. I mean, you have a beautifully precise channel there cut, and
But-
my experience with them is that they are all over the place.
And you don't want to sand them, obviously, because they're a nightmare.
Mm-hmm.
And so what I do is I make that channel a little oversized.
Okay.
And then I
Actually,
glue a very small strip of wood to the graphite bar, and then run it through the sander until there's only like 10 or 15 thou of wood along the edge, and then glue it in nice and snug.
Yep.
So those are the bars that I have. I picked the widest one and then left myself a tiny bit of wiggle room. But this does fit on here, or it did when I machined this one. It fits on, that one's a little loose, and it can be a hair loose, but this is from the batch that I just did recently, so my guess is it's going to be a little bit more snug. It's nice if it's snug. It's so snug I can't get it quite to fit right in there. Let me show you. Boy, that doesn't want to go in there. Humidity. Anyway, that's how snug it is. You want it, oh, there we go.
Yeah.
Okay, so I had to actually push it down, so it is a little more humid here. And then I'd run some tape along here to keep it from sliding around on this thing. But, just make them all the same and make them a little oversized if you're doing a graphite bar. Otherwise, that's not important. Your truss rod can slide right in. So let's see what comes up next. So we've got, this is another thing that is just a tool I made because I want consistency when I'm doing this stupid joint. It's just to draw the volute, the dart. And it is, I've got a center line on there, and I've got this thing sized exactly to this. And so it just makes it really easy to slide it up here. And I think some of this got out of order. Let me first read, because I think the slides are not in the order I loaded them on there. I'm going to read through this thing so you get a sense of the order that operations have to be in for it to all make sense. So you've cut the back at the right size to match your head plate thickness. And then you can cut the ends of the tenon to the correct angle and lay out the neck from that point. That means I've got extra material here, but I just cut this guy. My neck joint is at 1.3 degrees. I cut that, give myself a tiny bit of extra room, an extra 30 or 40 thousandths, then come back from that point and draw my 12th fret or body joint here. These kind of necks were only on 12 fret guitars at the Martin Company. I am offering them on 14 fretters, so you just mark whatever the body joint is there. Then you can lay out where your nut is going to go. Pretty simple. Draw that. Then, give yourself a little bit of extra here. You're going to cut that. This dimension is going to be critical later, just because I want everything to register the same. I don't want to have to make micro adjustments every time for every neck. I'm doing a small batch here. So we're going to cut the ends of the tenon to the correct angle and go through the process I just told you. Mark the body joint, lay out the nut line, lay out the end of the beak point. I go 2.2¼ from the nut. Now the volute, the length of the volute ends up being a little less than 2¼ I've seen a bunch of, as you have too, David, a bunch of these. They go anywhere from like 2 inches to, well, even that, less than that, under 2 inches to almost 2 1/4 full. I like the long ones. They're more elegant to my eye. Short, fat volutes just don't seem that sexy to me. So I like a nice long volute. You can run into some issues if you get wide and very long, especially if you're using the banjo tuners, because you can get fairly close to the volute, the tuner housing. You know, the banjo tuners are fairly clunky on the backs. The other issue is if you're doing slot heads, the way Martin used to do their slots, they would arch the inner walls of the slots. So the opening of the slot was quite large, and on some of them, it can almost be touching the back of the volute. But you'd have to, I've never seen one touch, but they get very close, so it's something to be aware of.
The other thing I've noticed too
Yeah.
is that the width of the volute at the base,
Mm-hmm.
you have to be careful about how wide a nut you're doing, because if you make the width of the volute too wide, you're going to have trouble getting the neck the neck contours at the nut to work into where that volute wants to transition into the
Absolutely,
rounded part of
sure.
the neck.
It determines what you can do with the carve there as well.
Right.
Yeah.
Yeah. So
Yeah.
you don't want to have it too wide, because then you're like, you know,
Yeah.
you can't get a nice smooth curve to right that very end of the neck where it transitions
Yeah.
into the head.
Yeah. I don't think I wrote down in here the width of this guy, but we could measure that. I think it's 3/4 here, but it changes in the final product. It gets wider than that because you're removing a whole bunch of this material, and it is at 8 degrees, but it doesn't change by a lot. But that is one of the things that the first time you go through this, if you don't have somebody give you actual dimensions, then there's a lot of guesswork. John Grevin, I stole most of this info from John Grevin, and he has a tutorial on his website. He's the guy who came up with using the sled at 8 degrees. And like I said before, you can choose, the degree isn't that important. But he chose 8, so I said, I'll go with 8, whatever. John Grevin, Greven. And there's a tutorial. It's a quick tutorial. It's just like maybe 10 slides on his website. And he walked me through this process the first time I did it. So I owe this whole process. He ought to be up here talking about it, but I'm doing my version of it. It's mostly, I call it the Grevin method. So it is a little trickier because you don't know exactly what it's going to look like until you get down and finish one. And you have to make sure, the first time I did it, I had to make a bunch of adjustments and, go through the whole process a few times to get the dimensions exactly where I wanted them. So then I'm laying out the beak end point 2 1/4 inches from the nut. Then I cut the end of the beak on the table saw, which is just a simple, just cut it off using your miter gauge. We laid out the center line, lay out the dart using this guy, lay out the bird beak, and there's separate templates for that too. A lot of this had to do with creating templates. This guy corresponds to this. I make this exactly the same dimension as my blank, of course, and slide it over here and just draw your lines on the side of your blank. So I've got this thing, none of this stuff has been cut, it's just a squared off end, and I just lay the template on there and draw that top line as the critical one. Now I had to deal with, I use a 3/8 by 1/4 graphite bar in my neck, which makes this a really tricky joint because that's a lot of material here. I can't go any thinner than that because I'm going to get into my graphite bar. My graphite bar, there's only 30 thou or less underneath that bar and that table saw cut. So it's really, I'm pushing it up as far as I can without getting into the bar. So that makes it a little tricky. I like to place my graphite bar in the slot about 20 thou or 30 thou deep, and then put a little wooden strip over it so that I can then level the board a little bit, or the surface where the fretboard is going to go. Also, when this joint is complete, this surface right here and this surface right here, you're never going to get this joint so that they meet up perfectly. I mean, it is really difficult to even get it in the ballpark, but you have to be in the ballpark, because if you take too much off of this and this to line them up, then you're into your graphite again, which you could do. I mean, if you had to, you could take a little off the graphite. It's not going to weaken it, but you'd have to do it on the belt sander, and it's just nasty, so I'm trying to avoid that. So I've got a little bit of wood on top of the bar so that it gives me a little bit of wiggle room to get that nut exactly where I want it, and I can take some off the top surface. So I've laid out the top part of that. I have a second line here which tells me the gap between the top one and the dart, and then I have another one with the correct angle, and I lay that on there and draw it. And then it's pretty simple. I'm back to the Grevin method, which is just cut this stuff out on a bandsaw. So I rough cut all these pieces, staying just back of the line. It really helps if you have a bandsaw with very little set that is very sharp, so you can cut, you can cut really close to a pencil line very accurately if you've got the right tool. For this last batch, I didn't have a saw that did that, so I had to stay back of the line a little bit, and that made for a little bit more cleanup with a sanding stick, which is what I do on these surfaces. Everything else I do on the table saw. Grevin does everything with sanding sticks, and the blade I would recommend is the Wood Miser, which is a resaw blade from Highland Hardware. Do you guys know the Wood Miser? It's not a great blade for resawing, in my experience, because it's a very thin blade, and it's only 3/4 of an inch deep. It's very sharp. It cuts like butter. I mean, parts of it are amazing, and you can get tremendous yield. But if you're cutting an 8-inch piece of rosewood with this thing, the blade will bow in the middle unless you get the you have to set the lean or lead of the bandsaw perfectly, which is near impossible to do. But it works. It's worth $30 just to cut this thing accurately. I mean, it's really a fantastic blade for that. It leaves an almost perfect surface that you barely need to touch, and it cuts really straight without wander. Very little set to it. It's a great tool for that. But it's not necessary. You just cut back of the line a little bit more. So I think I just covered some of the stuff on here, but we'll go through it. So I've laid out the bird beak on templates 1 and 2. And then I cut the dart sides on the 8-degree sled. So this is the sled. It's just a little wedge at 8 degrees with a spline in it for your truss rod slot. Lay the guy on here. And this is the one I couldn't get in here before. Then it magically went in. Hold on. Oh, it's tricky. Okay. Make sure it's hanging over a little bit. Tape it in place. This one's on there pretty good, but you want to tape it so it's very easy to control on the saw table. And then you have to be very careful. Lay out which angle you want on here on the end of it, and double check, because it's so easy to do something and cut the wrong side at the wrong angle. It seems like that's obvious. Trust me. This is why you're going to do test pieces out of poplar first. And then you just cut along that, you just lay it in there and cut up to your nut slot. Stay back a tiny bit. You're going to clean these up later with the table saw. Right now I'm just removing material pretty quickly, except this cut and this cut on the sled I don't do on the table saw. I could have adapted a jig to do it, but I was like, I've spent enough time making fixtures for this thing. And those are easy to clean up with sanding sticks. This stuff is easy to do. If you get next to your line and then you do that with sanding sticks. Then you can lay it out flat back onto the table saw and cut out the middle section. So that guy gets cut out. Again, stop back of the nut a little bit. And then you lay it back on the sled again, goes back on the sled, and again, tape it down so it can't slide or something can go wrong. And I cut out all the material will just fall away, and you'll have pretty much what looks like a finished bird beak. You put it on the sled again, and you cut your cheeks. So you're just going up again. Do this on a test piece because it's very counterintuitive sometimes, and you want to make sure you've got the right angle. The sled is facing the right way when you cut those. You may not be able to pull that off on a Jet or Delta 14-inch bandsaw. A 12-fret neck blank will just fit in there. 14-fret neck blank, you'll need a bigger saw. However, you could easily do that with a handsaw, with a dovetail saw or something. So it's not a big deal. And we're just removing excess material here anyway, because now we're going to shift over to the table saw stuff. And for that, I'm going to show you some pictures, and we'll see what kind of order these guys show up in. So there's my volute template. That's what it looks like after being drawn out. I actually use just a really fine point ballpoint pen for that. I found that works well enough. You don't need to knife scribe it or anything. There I am cutting the, you obviously stop short of, that's why these guys are so oversized. I just want to stop short. I really just need to establish, you need to establish a fairly long run here of flat on the back side of this, but not cut into your heel area, because there is an operation where we lay this flat surface on, I'm not just establishing the back side of the beak, I'm establishing that, and the thickness is critical there, but the flat surface is critical, so I can put it on this jig that you're going to see a photo of, which I didn't bring, and that's for cutting part of that inner beak part. So
The depth of that arm, the arm of
the depth is 1.325, and it's on these handouts.
Oh, okay.
And that will be the, on a volute, on a Martin volute, you've got your neck coming down like this. It kind of goes like that, and then it goes like, there's your volute. So your headstock would be, there's your headstock. And your dart looks like that. So, that's exaggerated. It would probably be more like that. This is the surface that you were establishing right there. That's the thickness. It looks funny coming along here. It's actually, that's because this is at an angle. That's actually at that angle, and this is like that. That drawing looks great, doesn't it? We'll edit that. But you can see here, if we just plug this guy in, this one corresponds to that one. That one's not a fully finished, oops, here we go. This is not a fully finished neck. I only spent a few minutes fitting this off of the jigs, so it was pretty good. But, you've got this surface and this last little bit of the volute are parallel. And that distance is determined by, the dimensions, how long you want your volute to be, and the thickness of this plate. And the thicknesses don't vary that much. You're not going to see that much difference in your volute length. I have 3 different sizes that I cut these to, but you don't need to get that picky. So, but I want a nice flat surface on there because one of the jigs is going to need a flat surface. You can't just bandsaw that one. So you got to run it in there and then pull it back, which can be dangerous. So just be really careful, or turn the saw off, or whatever you want to do. All right, and then there I am just using the centerline template. That's established. You've seen some of this stuff before. I'll just go through these quickly. I'm not sure exactly why these are out of order, but oh, there's a second one. Oh, this is the unedited version. Okay, that's why. And there they are. And they're all, you can see if you look closely, the points don't line up absolutely exactly with my center line, but they're really close. You know, we're talking 10th thou or something like that. It's close enough. And I'm going to sand those by hand later, and I can get those points exactly so that they dead end right on that center line. And that part isn't that critical. The reason you want that to be accurate is because this drawing, that line that I drew here, is going to establish this part as well. And that I want to be accurate from each piece. So I want it to be as accurate as I can get it. There's going to be some hand fitting, but if I'm really, really close and my lines are the same every time, I use the same template every time, then that's going to mean when I try to attach these guys, they're going to be almost fit. I won't have to spend half a day hand fitting it. So that's the reason I got really into doing everything with little templates, because they're easy to make and it just helps the process go quicker. So there's the first bandsaw cut. And there I am with the templates. Yeah, sorry, these are a little bit out of order. But there's template number 2 establishing that angled line.
You have 2 different templates you do because you do 3 different.
Yeah, actually, for each, this line up here is the same no matter what the thickness of my necks are, because I'm restricted by the depth of the graphite rods. You know, it's 3/8 thick, so all those are the same, reading off of that surface. So that I can establish with this. And I'm going to, and this is fine tuning. This is going to be fine tuned when I switch over to the table saw later. So this just gets, I'm cutting out some waste here, but you know, on the bandsaw, I'm getting in there and cutting that out. But I actually am going to get a table saw in there. Can you believe it? You know, and I use a thin blade. I don't use a full 1/8 inch thick saw. I'm using one of the 90 thou kerf blades, and it'll just get in there, barely. And that's when the fun starts. So there's the first cut, taking the waste out of the middle of the beak. Call that the beak. And so I've made those cuts, and now I'm coming in and I'm just got the thing on the sled, and I'm taking off the waste material, and it's just going to fall off in little pieces. And again, do it on a test piece first, because it's really easy to put that guy on and run it on the sled backwards. Sometimes it's counterintuitive. It seems like it wouldn't be, but it's easy to mess that up. And there they are. Now, you know, if that were John Grevin, he would be at sanding sticks and have the whole thing assembled in like 10 minutes, you know. But I'm just getting started. So you can see here, I've got a little bit of material on the bottom of my slot. It's not a lot, and I'm going to take most of that away with a table saw pass. So it's really pretty thin underneath there. So that makes things tricky. And I've got, you know, my bandsaw kerf is in there, but it's okay because these guys are cut a little bit long. So I can be a little bit less cautious here. I'm trying to do those cuts really accurately, but you just give yourself a little room. Don't cut past your lines and you'll be okay. So here comes the first thing. This is just a mortising jig, but it's a homemade one to fit the necks better. You know, it's just a bunch of plywood in a box with a perfectly straight, you know, a little bit of testing until everything lined up just right.
You don't just cut that freehand, obviously.
You could. I mean, the Martin guys probably use dovetail saws, honestly. Yeah.
I'm guessing that's
Yeah.
Although you don't know, they had very highly developed machine.
They did.
tools,
They
even
did.
Way back when they were doing these.
Yeah.
If you look at the series system of belts and pulleys
Sure,
and stuff.
sure.
So they might have been doing something very similar to what you're doing here.
It's possible because they were cranking those out
They
pretty
were
quickly.
Indeed, and
Yeah.
they made them well.
Yeah. The thing is, they're not all the same. So they were drawing using templates, and then, there was a lot of handwork in there. They're not that consistent. When you look at them, and I buy old. I should have brought one with me. I buy beat up old Martins just for the necks. There's one that I tried to get from Walter Lipton for years. It was my favorite volute. I finally got it. It took me like 5 years to get it from him. It was like an 1870s Martin with a very yellow amber neck, but the volute was the sexiest thing I'd ever seen, and that's what I copy. But anyway, so that is just it's just a squared up box with a backstop here so that I can line it up. And this is another reason cutting this guy to length is important, to keep them all very accurate. Because if you want to do more of them and you put them on there, on one you might be cutting into your nut cheeks, So that's why that distance from your nut line to the end of this needs to be established quite accurately.
You have to make sure you got no lead in your fence, right? It's just parallel right to that blade as close as you can.
Yeah, and there's some it took a little testing. I went through a lot of poplar, just tweaking all those cuts so everything was accurate. A little bit of tape here, a little bit of sanding here until I have a jig that I can trust every time. I just throw it on there, make sure, as you clamp it down, you want to make sure it's snug in there. There's, like all good woodworking joinery, you just got to make sure it's mounted properly and your jig is set up properly. And it's a little scary at first because you got a lot of blade, hanging out of that thing. But it's not that bad. It slides along, your hand doesn't get anywhere near it. I just put one hand on it and slide it along my fence, and I think it's called a VersaFence maybe, but it has a micro adjust wheel, which is nice. And so I run a couple of tests before I start cutting real mahogany with it, and I just on the test pieces I just slide it over until I'm about 20 thou shy of or 30 thou shy of my graphite rod.
That blade straight up and down at that point.
Yep, everything is square, square, square. So
Confusing between Freeman and the other guy that did the thing in an American Literary magazine, because they're using different angles.
Yeah. This is really, it's the Grevin method. But Johnny didn't use any, he's not going to be troubled with making tooling, He did make this thing. But he told me later he gave up on this and just cuts everything by hand anyway because he thinks it's fun, which, I have to agree, it is fun to just like take a little dovetail saw in there and hollow it out with a chisel. But I wanted to be able to make like 10 or 15 of them and be done with it for the next couple of years because maybe I'm not as smart as John, but every time I go through this process, I have to relearn it. So that's why I wanted to be able to reproduce it in mass, because I'm like, I can't take time to relearn it. I have to ship guitars. So there you can see it, a little close-up of it mounted in there. Now we're getting to the real deal. That is just, again, it's just a mortise jig at an angle. And it is making this cut on the table saw. And what you do is it doesn't really matter which cut you make first. You can make the 90-degree cut or the angled cut. I use a thin blade again because that gap between those two is quite small. And what you want to do is get the saw up close and then just the tiniest little turn until it is just a hair below your nut slot. Now right now I've got bandsawn, these are bandsawn. So there's a little bit, there's maybe 30 thou of extra material there. What I want to do is bring that saw up slightly until it's just cutting into that. That way I know I'm as close as I can safely get without getting into my nut cheek. And I don't know, I think I have a picture of the thing mounted in there, but again, it's the same as the other one. It's just in there with a couple of quick grips. No, okay, so I don't have it. The first one rides, well, I'll go back to it. Let me see. I do want to explain one difference between these two things. Oops. Okay. When you put this blank in that one, you are now, let me see where, like that. Okay, so here's your jig. It's in there like that. This is going straight up and down. My jig is angled. I didn't want to mess with setting the angle on the table saw every time because I don't have any way to do that as accurately as this needs to be. I wanted to leave the blade at 90, which I can measure extremely accurately, and then make a jig that is not going to change every time. So that's why I've got that. And also, I needed to get a lot of blade exposed, and I just felt safer keeping that at 90 and building a jig. But on the first one, this sits on this cut, the 90-degree cut sits on top of a little piece of plywood in the jig. For this cut, the whole thing, in order to get the depth of cut I wanted at that angle and everything, this sits basically on the table saw surface. It just worked out that way. I could have adapted it to probably not do that, but that particular jig, it does. And again, because of that, this distance again becomes critical because I want to be able to, although I am I'm fine tuning the height, but I want it to be the same on every one. So even if it's not, you can vary that distance. That part's not critical. The critical thing is everything's the same because it is registering off the tip. Does that make sense? It's just a registration point. Yeah.
That corner of your angle is just kind of going to meet that point, and not cut up into the wood. It wouldn't matter because it's disappeared, I guess.
Which point?
Well, you got your straight one and then you got your angled one.
Yeah.
And of course, it's a narrow saw, so you really don't have much width of the tooth. But
no, if you use an 1/8 inch saw, I got away with using an 1/8 inch blade on this one, which is for the thicker headstock, because it has a larger gap there. Because the back of this guy registers on this. So the distance between the top and the bottom of that dart, that is the same distance plus 25 or 30 thou of your head plate. So the thicker your head plate, the further that comes down, which is going to change the size of your volute a little bit, but not by much. Depending on, I do have like I said, I have a fairly thick one. I like a thick head plate for slot heads, thicker than the vintage Martins a little bit. Some of those, the tuner, the sides of the tuners, like on a 3-on a plate, they're almost level with the top of the head plate, the head veneer, which I like to have a little bit of extra thickness there.
Now, do you center the tuners on the mahogany, or do you
no, I center them on the whole thing,
on
including
the
the
whole
veneer.
thing,
Yeah.
Not on the mahogany with
Right.
the plate raised
Yeah.
above it. Just right.
I center, yeah.
Yeah.
So I have a fairly thick one and I have a really thin one. So that's one reason I was very meticulous when I cut the side, the depth of this. It's because I want my volute to pretty much be the same on each of those different versions. But you don't need to get that picky.
Grevin comes, he saws that right to a point and he's trying to get that out, but the machine part is really better because you can get in there to chisel or whatever you got to do.
It just simplifies it. I don't trust my hand skills enough to pull this thing off without at least starting with some consistency. If I got in there with a bandsaw and then had to sand the underside of this surface, There's no way I'm going to get that thing and then this surface accurate to the point where one side isn't going to be angled a little bit. And then when you fit this thing, it's like fitting a dovetail with an extra element in it, which makes it near impossible. Because you've got this angle, you've got these angles, you've got this wedge factor, and you've got this. That's too many variables. It really is. You have to, I'll get to it later, but one of the things you learn when you try to actually fit one of these, you have to eliminate one of those variables. And you do that by making it slightly oversized and then shimming. And there's no sin in that. Otherwise, you're going to be there for 5 hours trying to fit the thing, and it's going to get loose, and you're going to go, oh, no, well, now what do I do? So then you've got one of the variables is loose anyway. So you might as well start by eliminating one, getting the other three perfect, and then putting a 10th shim of something along the edge.
Show's perfect.
Yeah. Oh, it'll be perfect, and it'll be just as strong.
Right.
There's nothing wrong. It's yeah.
I think the thing too, you shouldn't feel somehow lesser because you're doing this by machine, because all the really elegance of this joint is going to be created by hand anyway.
The carving, yeah.
The carving. The only thing that you're really going to do by hand is maybe save yourself this amount of trouble, but making some of the joints less precise than they might have been otherwise.
Yeah, believe me, this thing is, I admire somebody who can pull this off mostly by hand, but it's hard enough doing it this way. And there's, getting all this stuff tweaked to the point where it actually works, because the tolerances are so tight that getting it to the point where the machining all adds up to something that's going to work is hard. It may even be harder than hand fitting it, but it's worth it, because then you can crank out 10 of them and then you put them on the shelf for the next couple years. You don't have to go through the process every time. So here I am, where I'm going to cut the 8-degree angle and get my nut cheek exact. And I don't know, I don't make my own necks generally. I have my necks CNC carved, my one-piece necks. But a lot of guys who make their own necks know how to do this probably better than I do. But I didn't want to go up to a pencil line or have a stop registering off here. I wanted to have a registration point off of here. Another reason this distance has to be really repeatable and accurate. So I've got this block here, and what I do with that block is it allows me to tip this thing 8 degrees this way. So I tip it, and then I make my cut, and then I flip it over, and I've got this block. The reason that block is there is because when I flip this over, the heel would have hit my fence. So I have to move it out, and you just have to make sure that guy is lined up exactly 90 degrees to the blade. And then when you flip it, it cuts the other side, and they are in exactly the same plane. It's pretty basic neck making. But the only tricky part is there's an 8-degree wedge. You need a 2-part wedge. One of them goes underneath the guy, and the other one, oh no, wait. I put the little one underneath it, and the other one goes against your cross piece. So it's nice and solid. And then you can just put a little clamp on it, like I've got, and run your sled. And then you flip it, and they line up perfectly, which is critical for this joint. It's not like if you had a joint down here, a lot of guys cut your tenon on a table saw that way. And if it's off a tiny bit, so what? You get in there with your chisel and your sanding stick and even it up. That's no big deal. But for this joint, you can't do that. It has to be dead nuts perfect for this thing. When it all comes together, this surface right here and this surface have to be perfectly in line. There can be no visible gap there. And so that's why I was like, okay, this has to be just right. Otherwise, there's just no way to make that work. You can't fake that, like you can with a neck tenon at the body joint.
When you put that over and you do it the other way,
Mm-hmm.
where does your wedge go?
Okay, so here you can see it's wedged up against the fence. And so, oh, I'm really glad you said that. Because this is just a piece of scrap wood, but I put a spacer in there. That answers your question. You extend the fence out with a spacer. So, you know, if you can see up here, I mean, it's, if this were my table saw fence or the back of my sled, I would put the spacer in there, put my 8-degree guy in there, put this underneath this guy, and then everything gets wedged like that. And then I can run that at 8 degrees, and you know, and everything works out. But you do need the spacer to, you know, just to create clearance for the heel. So you need, yeah, you need 2 of these guys, both cut at 8 degrees, a small one and a larger one.
Next time you do this, like in 3 or 4 years, will you be consulting your own slide presentation?
Yes, and
As to where
I'll be
everything
looking at
goes?
this. I had notes. I took meticulous notes the first time I ran through this like a couple years ago.
Yeah.
And I went back and read them, and I was like, man, I left a lot of stuff out. That's why this is so meticulous. Teaching this course is great because next time I go back, I'll remember how to do it, and it'll still take a while to really figure it out. But yeah, and there's also a little handout here in the middle of this thing that shows you some of the dimensions that I use. And you can change them to your own taste, but certain things are critical that, you know, that you need to pay attention to when you do your own version. Okay, so there it is with the spacer. Oops. Okay. Another shot at that. And so you just make a wide stop block. You know, I just have a wide one so that when I flip it, it still has a registration point that's accurate to the same distance from the saw. And that's why you have to make some test cuts and make sure that everything is perfectly square to that saw blade, or it ain't gonna line up. But it's easy to do. You know, you just make a few test cuts and tweak it a little bit. And that just shows you how clean it can come off of there. I've got a sanded, the sides of the volute are just off the bandsaw, but it just shows you how close you can get when you have an 8-degree angle. You know, you can come right up there. And then all I got to do is chisel out. I'm going to sand this surface, and then I'm just going to take a chisel and clean that tiny little nub out of the corner, and it's just dynamite. Okay, there they are out of order again. So it's an older one that you've seen. See what else shows up here. So that is how clean that thing will look just after, it literally takes 3 minutes to sand the saw marks off of the side of that thing and then chisel the corner out. And that's how close I am. Now I get in here with a 1/16 or 3/32 chisel, and you hollow this area out. There's no structural reason it needs to be, you know, in line with these cheeks. And it'll hold everything up. So you just hollow it out with your chisel just a tiny bit. Just make sure there isn't a high spot in there, you know. So just get in there and take that out. And this area right here, I've got this surface where this part is cut out that's going to go and mate with that. The area in between that trough, you can also take that and bring it, hollow it a tiny, tiny bit. Just so you know, nothing inside there is going to hold up the rest of the joint. It just eliminates, you know, you want to make sure you do that step, because if you don't and it's holding it up, you're going to assume the joint isn't closing for some other reason. the other 4 variables you have to worry about. And then you'll overcorrect those and you'll end up with a loose joint. So just eliminate that and make it hollow. And there I am with my little dagger. That's like a 16th, it's an old 16th inch chisel. Okay, now we're on to the head plate. Again, in this process, you just want to make sure these are all the same. And this distance, just create a flat block that is the right thickness that you want. And you've calculated that into making, the first part of your joint, so you know what that is. This gap, G, if you look on this thing, G is that gap, and that gap has to be a certain thickness, and Y also, which is the thickness of your head plate, you add about 25 thou to that, and that's where the bottom of this guy should intersect your nut. Now it sounds complicated, but really I'm just saying, just make this dimension, that thickness, make it line up with where this guy is, and add 20 thou. So it's pretty simple, and you just do that with your tests, on your poplar or whatever you want to use for your test cuts. Just line it up, and then we get into making this. And one of the secrets of this is the first step. Just cut your angle in there, and make sure that is very accurate. Get your angle exactly where you want it for this guy. And, so it's like a standard head plate. Then you're going to cut an angle into this thing. Have you guys all seen this thing? You can see the pocket that I'm cutting right there, and that is in a box. It's in this box, and I'll show it to you, and it's at this angle. So when I route it, I'm routing at that angle. So I set this in at exactly 15 degrees. Which is what this was cut at. That's exactly 15 degrees. You can do whatever you want, 12 to 15, somewhere in there. And that angle, this guy is going to be tilted to exactly 15 degrees. I don't measure it. I measured it initially, made some test cuts, and then just shimmed it with tape until it was about right. And so why don't you pass that around? You can see this one has actually like a 10 thou shim in it. That's one of the first ones I ever did. And this is the jig that makes it. This is a variation on something that John Grevin developed, where it just holds that. You then put a little thing on top of it with the correct angle. That goes on my jig. Whoops, I've got it taped on here so I didn't lose it in travel. So this guy fits nice and snug, and it can slide back and forth a little bit, so you can adjust it. That fits in here. Oh, there's a head plate in there now. So you guys can come check this out. It's just a simple mechanism where I want to be able to center everyone, although centering it isn't super critical because it's oversized a little bit. But my head plate fits in here. It's got a little shelf that it sits on, so it's at the right angle. Put it in there. I bring it forward with a little wedge. And then I back these guys all the way out, and then I turn them roughly equally until the whole thing is centered. And I've got sandpaper on these little wedges so that the thing can't move. Just holds it in place.
John, for making a slot head guitar, once you cut your ramps, does any of this joint show in your slot?
I haven't
head
made one
ramps?
yet. I haven't made one out of slots
yet. If you look at
yet.
the old ones,
Yeah, I haven't finished one. I've got all the blanks cut, but I haven't actually carved one yet.
For a solid head, none of that joint's going to show.
Right, absolutely.
Anywhere. But for the slotted head,
I don't think they would on this one, and it may. I don't think. I don't think John did slot heads like it, but the 8 degrees is going to keep it from showing. If you look on the old Martins, where the angle of this cut is like this, and this guy is at like 35, almost 40 degrees, it's going to go into your ramps for sure. And you see it. You see the joint there. Yeah. I doubt you would see this, but I haven't carved one yet.
Okay.
I've got all this. I've got all these. I have a stack of like that many heads that I routed and that are made, but I haven't done the slots and assembled one yet.
So it'll depend too on the width of your slots and
Right.
you know
Sure.
the layout, the display of the head,
Yeah.
the layout of it. But
So I could get fancy with this and get a little 8-degree bit in here and cut this, but I just cut it with a standard bit, and then the sides of this guy. Whoops. Hold on a second. The sides of this have to be angled at whatever degree you've got here. This happens to be 8 degrees, so I have to hand cut an 8-degree angle onto the edges of these guys. And again, to do that, I just made templates. And they're over here, but they're pretty simple. I just have a template that corresponds to this end point, and I just line it up where it disappears into where it's at 0, and and then just chisel it in a little sanding, and it gets you there pretty quick. I did make a couple of. The reason I brought these is because I wanted to at least show a couple of things that make it easier. So here's my little template. It's got and I just slide it along here, and then I make a knife cut and then throw some chalk in there because that I want it to be really, really accurate. So a pen line or pencil line isn't going to cut it. And then I just chisel it, and then I have a sanding block that's at an 8-degree angle, and I just lay it in here and just like fine tune it. And you can use this later when you're doing the final fitting if you need to enlarge this a tiny bit. This just makes the sanding a little easier, but any sanding stick would work. But this keeps it because it has a flat surface. Like a wider one would be better, but you can't fit a wider one in here because of the narrowness down here. So that's as much as you get. And I register it on the bottom, and it keeps it at 8 degrees so you don't get a rounding of the side. That's what you want to avoid. It'll just give your joint a lot more integrity because that's where a lot of the strength of this joint comes from, is that edge grain right there.
So the trough is 8 degrees on the side.
Yep.
And then what's the taper?
The taper is, I'm not sure. It goes from there to there. It goes from there to nothing. I haven't measured that angle.
Okay.
But I can tell you the distance on mine, they usually end up around 2.2 inches long. And I can't tell you offhand what the final dimension is, but if you want to email me or something, you can do it. Or if anybody has some calipers in their pocket, you can measure this. But that isn't the final dimension. So I don't know what that angle is exactly.
You just pulled off the...
Yeah, I just transferred it, using a gauge, and made some test cuts until, and I eliminated some of the variables when I'm making my test cuts. I wasn't fitting this part. I was just making sure that when this guy went on here for my test cuts, I just took a piece that wasn't tapered or anything and stuck it on here until I got it so that the angles matched.
Okay.
So for your test cuts, when you're establishing this, you get it close, and then you just fine tune it using a piece that doesn't have all those other complex elements in it until it fits perfectly, and then and then I just route it. And so what else do I need to show about that particular thing? I think that's it. And then we're going to get into the fitting of it, which I don't really have too many pictures because it's just a guy with a chisel and a sanding stick. So let's...
I just had a quick question.
Yeah.
It's actually about your sanding sticks. You said like 8 degrees. How do you approach setting an angle on the sanding stick? Just using your table saw? Or?
Yeah, exactly. Yeah. I'm sure that's what I did. I don't remember, but I'm sure that's what I did. I just cut it on a table saw. So there's that little template I was telling you about, and I knife cut that and throw some, you can see a trace of the chalk in there. But, I put on the optivisors and I can cut right to that knife line so that they're very repeatable. The whole point of this process is the repeatability of it, because it's not going to fit perfectly. But if all the variables are really, really tight tolerances, then the fitting goes way faster. It'll be pretty quick. And it turned out the first one I did on this run a couple days ago almost had a perfect fit right off the saw. I was ecstatic. So there it is. You can see the little bits of chalk. I don't know if you can see it actually. Is it close enough? You can barely see the chalk and the knife marks there. Oh, and there's another one. Okay. How are we doing on time?
208.
Okay. So there I am. Oh, okay. So this guy, again, 8 degrees. And you can use this. I use this kind of block to chisel angles into things all the time as a chisel guide. You clamp it along here. You clamp it right exactly at your scribe line, and then you could chisel this, but the problem is the angle that you're chiseling it at, the chisel does not want to cut in that angle very well. It's awkward. It's just a tricky thing to do. You've got to have a really long chisel. You have to approach it from this side, or depending on where the grain is flowing, you have to, you can't come at it from this angle because you're cutting into grain, so it's just tricky. Yeah, maybe I should get an 8 degree router bit. That would simplify things. I think that might be my next step when I do this again. Yeah, because it doesn't take long. The sanding sticks make pretty quick work of it. But so there it is. I do use that as a guide, and then I'll actually clamp it in place when I'm using my sanding stick, which kind of keeps me from, when I get down to where I need to be, then it starts rubbing against the block. And that way, it really does create a pretty accurate edge pretty quickly. But I think an 8 degree router bit would be a lot smarter. And there's the finished thing. It looks real clean. The edges are clean, and they aren't rounded at all. It fits quite snugly. That was the first fit off the machine, which I jumped up and down when that happened. I was like, oh my God, that's close. And the fit was just like nuts. This is from the new batch. The B stands for banjo tuners. So this got one of the thin plates. This is a test piece. It doesn't really match that, but it doesn't matter. So I just stuck it on here. And you guys, let's turn the lights back on. Is it that one? And you can see it took me about 5 minutes to get that kind of fit. Now this is a perfect fit for gluing just about, because it comes off pretty easily. I can do that, and it's on there nice and snug. It wiggles a tiny bit this way, edge to edge. So I'd have to deal with that, but it's almost perfect, and it was super fast. You don't want it too tight, because you're going to glue this thing with hide glue most likely, and it's going to swell the joint. And what that's going to do is this edge has to dead end against that point just as it's snugging up here and in here. So if those swell, you're going to get a gap between those two things. They won't close anymore. So you can't leave it, you can make it nice and tight and you go, wow, that is the perfect joint, and then try to glue it and it's not going to work. You can't force it in. So you have to make it perfect, and then you go in with a little sanding stick and you take a tiny bit off this edge, and you take a little bit off the back of this, and just 1/1000th of an inch or so, until all of a sudden, oops, it's a little bit loose, and then you're perfect. Then you glue it in and it is rock solid. Then I run a graphite bar through it, pre-cut the bar at that angle, and leave it a tiny bit long so you don't have much sanding to do. Or you could, I like it to be right up near the veneer just for maximum strength, but you don't have to. And then, then you sand this guy off, and you could stand on this neck, and that headstock would not break. It is so solid, it's crazy. I've done flex tests with my one-piece necks versus these guys, and these are much, much stronger. There's no flexing going on with this plate. It just doesn't move the way the other, one piece with the grain running that way out of it.
Does that end up being stronger than a scarf?
Scarves are strong, but this is basically a really complex version of a scarf.
John,
With the added feature that it has a graphite bar coming around, against that. So, I mean, you could literally almost do that, and I don't know if it would break. I mean, it's just ridiculously strong and lightweight.
Are you putting glue on the upper surface of the bird beak?
Up in here?
No.
No.
This surface. Are you gluing this surface of the bird beak to the bottom of the head?
Oh, yes, indeed. That surface is getting some glue.
You're getting some glue on.
And I leave it very large and uncarved at this point
Right.
because I want to be able to push down on that.
Have you tried not putting glue, trying it without any glue?
I have not. I've only
Because-
done a couple of them all the way through to glue up.
One of the things that I learned at the Romanios workshop in terms of like the way we made classical necks was
Yeah.
that we did a wedge fit on the inside, but where that side touched the inner cheek of the neck,
This surface.
or the inner cheek of the neck,
Yeah.
where you would carve it against the side, and you didn't want.
Oh, right.
When you wanted a really clean edge, you didn't put any glue there.
Gotcha, right.
So
Sure, because you're gonna be carving this.
Right, analogous
yeah.
to that, when
right.
you're carving it, you may want to modify the
Yeah.
line harder if it's been glued. If it's not glued, then
Right,
then
I see
you
what you're
can-
saying.
Then you can carve it.
I'd be worried about that point more than anything. I
Right.
mean, gluing it doesn't actually add any
You
structural.
might be able to glue in after the fact, after it was carved.
Yeah.
I just thought I'd suggest.
Oh, it's interesting.
It's
Yeah.
something to think about. Perhaps.
The ones that I have carved before, I didn't run into any issues.
I always find
so-
that when I make the solid necks like that, I always find, or even work up, let's say a Martin blank or a blank that already has it sort of machined, that join or that corner
Yeah.
of that is always problematic getting
Yeah.
it clean and square.
Yeah,
and
sure.
crisp.
Yeah.
So I'm just thinking if it's glued, it's just going to be that much more because you've got this
Yeah.
glue, which is harder and harder to
Right.
manipulate as you're
Right.
getting into that corner. So,
Yeah.
you know.
I don't know. It's worth trying. I'll think about it.
Down the middle.
And if
You could also do that. Just keep the glue away from the edge.
Yeah.
Well, that's kind of hard to do. He's got such a good fit. It's gonna want to just go right to the edge.
Yeah. Yeah, it does have to be a good fit. And this is an older one. And there's one little thing you can see in here. If you look really, really closely, there's a little gap right in this corner. And that is from, I used the wider table saw blade. And I need to either take a little bit more material off this to get rid of that saw curve in there, or fill it with something. And so that's something to watch out for. That's why you won't have that problem if you just go with a 90 thou blade, which most people have at least one thin table saw blade in their shop. If you just use that one, you won't run into that issue.
When you do glue your peg head onto
Yeah.
do you use any N10 pressure like with
Yes.
the bar clamp?
Yeah, I have a whole, I've set it up like this, and I have a little wedge system that I use at the end. I just put a stop block and a couple of wedges, and I wedge them in, and it goes that way. And then I'm also putting pressure, because I leave that flat during the glue up so that I can come back in here and go, wham, just to make sure that point, when it absorbs moisture, it doesn't curl up. You just want to leave it down. That's why I use a little. Of course, if I didn't add moisture to it, it wouldn't come up. But I don't want it to come up later.
Yes.
So I glued them down, the few that I've made so far, to completion where the glue up step
I
came.
think it's legit to take toggle clamps and pull that tongue down just a little, make sure it's closed.
You shouldn't need to. If anything, when you're doing this angle, you should have it touching out here before it touches in here. I try to get it exactly perfect, you know. So if anything, if you do this and you see a little gap in here, I would mess with your tools a little bit more until, if anything, you should see a tiny, well, I don't know. I've tried to get it accurate. So I don't know. I wouldn't want to see a gap there. Let me just put it that way. You're trying to do this thing where you're not seeing any gap here. And you can shim or play around with this on the inside where it's all hidden so that you don't get any gap there. But if you try to mess with this angle, you're going to mess with you just introduce all these other things that get thrown off, which is why I went through this whole circus, was, you know, just so that it was predictable. So that when I did that, I'm like, oh, I don't have to, you know, look at this and go, you know, that angle's slightly off, or this side fits, but that one doesn't. You know, there's so many things that have to all come together at one time. And you can see on this one, there's maybe a 3/1000 shim of maple. I think I probably took a plane blade and scraped it, you know, just good a shaving and glued it in there. This is one of the first ones. This was the early test that I did, which is why I still have it around. And, you know, so those were a little bit large, and I was like, okay, good. I'll just leave those large and fit all the other things and then shim that up. And the other thing you can play with is thinning this guy by a few thousandths of an inch. I try to do that toward the end. You know, if this guy is fit almost perfectly everywhere and it's still a little tight, one of the things that you can do to get it to go in there, you know, because you have to get that wedge to snug up exactly when this surface meets. So one of the ways to do that is to just take the back on a sanding stick and take a couple thou off, you know. So you have a bunch of different things that you can adjust with sanding sticks. After you do a few of them, it's like, oh, that's not that hard, you know. But if one of those elements is a little loose, you can't shim this one very easily. You can shim anything up in here very easily. You just can't shim the back of that. It's, you know, that's not going to work. So that's it for the bird beak part, other than, you know, then you go and carve it like a marten neck. One of the cool things that happens when you do carve this thing is you'll see these little corners. I'm sorry I don't have a finished one with me, and I didn't bring my 1870 neck, but it's a cool detail. Are you guys familiar with what the bird beak looks like finished? I mean, it's a standard looking volute, but it has these little dimples in these corners right in there that are left. And it's a little signature, which I do as well. I mean, that's part of what I was after in doing this joint, was to get that, you know, late 1800s neck look, and that's part of it. These little corners, they fill with shellac or finish when you do the finish. There's nothing you can do about that, but that's part of the charm of the thing. I mean, you don't glop a lot of polyester on there. You know, it's a very thin finish traditionally. These were traditionally Spanish cedar. They're all sunken into the pores. You know, that's part of the charm of those old necks. You know, they usually have like an amber color to them, not always, but you know, they have a certain look and a vibe. And the volutes are long. One of the things about the volutes that is so cool, as you can see in this diagram. Let's see if we can do this again. There's your headstock, and you've got your volute is coming out like this, and then it goes like that. The distance from here, and there's going to be actually, because this was a one-piece neck, this is really what it's going to look like. That's what it looks like. One thing, modern one-piece marten necks, this is short, and then it kind of goes like that. Because what they're trying to do is they don't want it, let's say this is the first fret, here's the second fret would be there, like that. They don't want the neck getting too thick in this area. The old martens start about 1.5 frets, everything starts to get a little thicker as it transitions here. And this area on an old volute, a bird beak neck, this transition comes really far forward like that, and it's almost hollow like that. That is a classic bird beak volute.
And actually, the earliest of the Martin necks, that is even much. In other words,
There's almost just nothing
yeah,
at the point.
It
yeah.
moved that.
Yeah.
That point starts very much forward.
I'm going to get rid of
that.
that.
Moves further and further back
Yeah.
in the 19th century until about the teens, where it kind of is where
Actually,
it
I'm going to
is
need.
now.
Yeah.
But the very early Martin Koopas, they taper all the way out to the end of a
Yeah.
very long
Yeah.
beak, and
Yeah.
then have just a little
Yeah.
return at the end.
It looks kind of like this. Here's your really long beak, and
exactly. And
there's this tiny little section right here that goes like this. You know?
and that point you drew
Yeah.
moves down
Yeah. And
pretty steadily through the 19th century.
yeah, and then you get something that looks more traditional like that. Here's your nut area, and you've got this line right here. The modern ones seem to do this. Then you've got kind of a rounding here.
Right.
The older ones, this comes way up here, and this is rounded a little bit. It's not left super sharp. Modern ones are left very sharp here. These are rounded, and then they get sharp here. And there's a rounding in this area, almost as if it had been used, you know, and kind of the edge had been softened. And it's funny that tiny little details like that are what make it sexy. Just little things that you notice like that. The second part of my talk was going to be kind of, or can be, we can open it up to discussion, just various elements of building in the Martin tradition. And there's a bunch of stuff to watch for, having to do particularly with necks. But we can get into other stuff if you guys have questions. One of the things I wanted to mention about necks was the volute details. Long and thin is better. The transition here, keep that low and make it a little longer, and it really helps. You can build your neck up starting somewhere in front of the first fret, very slightly thicker. If you try to push this here and then come like that, if you kind of do that, not only are you not having a, you know, part of the volute is there to strengthen, you know, the one-piece necks have the volutes, they're much stronger because there's this section here. If you kind of do this, it is inelegant looking and it's weaker, you know, so why do it? Unless you have a specific preference for that look, then go for it, you know. Another thing that is a pet peeve of mine is fat heels. This is a pretty stock 1930s heel shape. It's a little bit longer than it is wide. It's pretty much straight up and down. There can be a little bit of a curve back that way, especially on the early Martins. You see a lot more of that. By the time you get into the 30s, that's pretty much gone. But you really want to watch this area right in here. It needs to be smaller than most people think. And it's still plenty strong. It's not, you know, it's not hollowed out severely. But what you'll see, let's say, here's your surface. Here's your heel up here. And it comes down. You can get a lot of meat in here that looks like, I call it like fat old ladies, or not, you know, old ladies' ankles syndrome. And, you know, so there's your heel. This looks actually pretty good the way I've drawn it. Sometimes you see some that they come down like this and then they just do that. And it really changes the geometry of what you can do in here. The other thing you got to watch out for is this area. You really want to hollow that way more than you think. If you look at old Martins, they have this a slight V that comes in here, and then it transitions in here, and it has to be hollow in here. You have to bring that hollow way up into this corner for it to look right. You know, so you really have to chase this area with your files and scrapers. And if this were me, I'd take a little bit more off of this. This is a very old neck that I had done on a CNC back in the late 90s. So I probably take that little bit smaller there. And then you really want to hollow this stuff. Let me see, what else was I going to say about the heels? Oh yeah, the edge. Another pet peeve of mine is, now we're looking at a heel like that, and you come down and you've got that. A lot of old Martins, especially OMs from the early 30s, this is pretty straight. It's pretty straight. What you want to avoid is coming straight down, flaring, and then doing that. And here's your fretboard surface. I've seen that on tons of guitars. I don't think it's a good look. And also, you can't transition in here if you've got that look. Now, that's just my opinion. But if you put a very slight curve in here, and then don't avoid that S down there. And also, this should be angled. You don't want to go too far straight down and then do that. It really allows this transition with a French heel, with that point, to be elegant. So it's just one of the things to watch for. If you're trying to do a Martin vibe, you have to pay attention to those. And the easiest thing to do is just get a Martin. It doesn't have to be a vintage Martin. Just, get a cheap Martin, have it around the shop, and copy it. Like any Martin made has something pretty similar to this. They may not all be carved as elegantly as whoever the mystery guy in 1929 was, who carved like the most gorgeous necks. But they don't do that. And you can't do a Martin heel if you're doing that. Let me see, what else? I have a long list of stuff that drives Johnny crazy. So let me see if I can dig it up. And again, I want to say, this is just my own opinionated BS. You don't have to pay any attention to it. It's just stuff that I notice about Martin guitars that attracted me to Martin guitars. This is why I fell in love with them, because they paid attention to details. I don't do Style 18 necks. I think they're ugly and they're weak. Even my Style 18s get a volute. Even if it's a one-piece neck, I just always put volutes on them. Let me see. I already talked about head thickness, issues with the volute transition. Binding ledges, when I'm binding guitars, I always cut my binding channels a few thou too deep. Because if you try to cut very accurately, your binding's going to kick out a tiny bit. And, when I was working at Bourgeois, I bound 4,000 guitars. And in the early process, I was trying to bind very accurately or cut ledges very accurately. Here's your binding channel. And here's your side. So if you put binding in that, and it's exactly the same, you've got a purfling channel right here. And your purfling, you don't want that to be loose, so you want that to be snug. Your channels are never going to be cut perfectly the same if you're making two passes to do this, unless you have a custom cutter, which we don't have probably. So you leave your channel so that there's a tiny bit of a tight, it holds that purfling tight when you pull the binding against it. But now you've knocked this guy out a little bit, so now your binding's a little thinner than it started out. And then when you pull it all tight, it kicks this corner out. And so the entire thing has gotten thinner. So you're having to thin your binding, which is okay if you could keep it perfectly even all the way around the guitar. But guitars they're handmade, and your routing channel, your system, no matter how good it is there's going to be slight variations, especially in cutaways, or if you've got wood binding or something like that that's hard to deal with. Plastic's much more forgiving. But if you have a light colored binding that really shows up, if it gets a little thin in one area, it's going to be obvious. So why not make the channel a little bit deeper? And then, so if your channel is a tiny bit deeper, then your binding, let's say there's your binding thickness, or I mean your channel, and your binding is here. When it gets kicked out from pulling tape across it or rubber bands or whatever, now it's almost perfectly flush. So it doesn't take any longer to clean up. And if it sticks out, it can stick out a tiny bit, or it can even be in a tiny bit, but it's at this slight angle and it's still holding this snug, but your line right here is like that. And we're talking, this is exaggerated. But then when you clean up your side, you flush this up very quickly, and your binding up here where it's going to be visible from the front is not going to change at all. It's going to look perfect the whole way around. It's going to be exactly the same thickness no matter what you do. The only consideration is in your neck area, you can't have this in your neck area. You know, so if this is a binding channel in your neck area, it has to be perfectly flush, because you know, if you've got a neck right here, here's the bottom part of your binding, and here's the top, and your heel is here like that. You know, that obviously has to be perfectly flat. So you just grind a little bit more off the sides. We're talking 1/1000th or 2. It's nothing that's going to be structurally changing your instrument, but you get very consistent binding that way. You know, so.
One thing that I've discovered over the years is that when I was not really paying attention to the flatness of my sides, and I went ahead and routed my channels, I would get into trouble, because if the sides had a little bit of a wave, or if they had a little bit of an in curve or an out curve or whatever, even slight, it would affect the depth of the channel. So really spend a lot of time in your finish. If you have a guy doing your finishing, he'll really love you for it. Spend a lot of time getting those sides flat. Block sand them, sand them on a sanding whatever. But
yeah, do you guys sand on the belt sander when you're leveling sides?
Get it trued up as much as possible, because it'll translate into a better result with what you're talking about.
When I was at Bourgeois and started binding guitars, I was leveling with a Dynabraid and hard sanding sticks, or blocks it with 80 grit and 100 grit. And I was going to throw my shoulder out. I mean, I had 10 guitars a week to level, like doing this with 80 grit. It was ridiculous. So I went out to Santa Cruz. I was visiting my sister out there, and went to the Santa Cruz shop, and I was like, how do you guys, I mean, this can't be how it's done, you know. And Dana at that time, he was just transitioning from a guy in his garage, you know. He didn't know production stuff that much. So I asked Richard Hoover, and he was like, well, we do it like everybody does it, you know. It's nothing fancy. How do you do it? We do it on the belt sander. And I was like, no, that's impossible. It's too scary. But it really isn't. When you get used to it, it's a piece of cake. But you can put a slightly larger pulley on your belt sander so it runs a little slower, and that helps a lot.
What grit do you use when you're doing belt sander?
80 grit, but if it's fresh, it's really gonna, use a slightly dull one. And OMs in small guitars are a little trickier because there's less room. You know, try to start with, you know, if you're doing it for the first time, a larger guitar is easier and easier to control, and do one that isn't like, has a lot of curvature and warpage. You know, do one that you can measure and go, that's pretty close. A few hollows. Hollows, of course, are easier to deal with than high spots, because the high spots will rock a bit. But it's not as hard. You just lay it down there very gently to start with. It won't take anything off. It doesn't take anything off until you put a little pressure on it. And then you know, do this. Don't stop in one area or you create a flat. Don't try to get into the waist too far, you know. But it really is, it's indispensable. Yeah, just on the flat of the belt sander. Yeah, you just take the thing, and you've got it here, and it's, you know, the bottom bout is there, and you just lay it down gently and start rocking. And you know, and you mark it all up with like white pencil or chalk or whatever, and check it, you know, until you get the feel of it. Nowadays, I lay into it, you know.
Martin used to have, in fact, there's a famous old photograph of Earl Hartzell at the new sander. I think you can see that in a bit. Yeah. They had a big sander with a flat surface, and the belt was The
Yeah.
belt was vertical.
Yeah.
So like if you'd lay the top down on this big nice flat surface.
Yep.
And then work the body against the vertical
Yeah.
belt, which was.
That's crazy. Yeah.
That was the perfect.
Yeah.
But that's why you kind of hate Martin, because they had all these great machines, perfectly designed.
Yeah, I love those pictures of the guys with like 500 uke bodies stacked up.
Yeah, yeah.
And it's basically it's a belt sander. It's a vertical belt sander. In other words, the belt is this way, and the spindle, the turnaround for the belt is here, and he's using that as a spindle sander.
Yeah,
And he's
yes.
just whipping around. I mean, I can imagine those guys spent about 30 seconds per uke on that machine. It was like.
And those things were whisper thin. So.
Yeah,
But when you look at an old Martin uke, the sides are flat.
Oh, everything's dead flat.
Yeah, everything is beautiful.
But
So they were good.
the tops were dead flat too,
Yeah.
so they could take those rims
Right.
before gluing the tops and backs on, and like just like whip them around dead flat. Yeah.
Yeah.
And will that work well just on the small desktop or bench top belt sander? Or do you need one of the big?
You just need. I use a 6x48. Mine is. I mean, it's a pathetic Craftsman from the '60s. I mean, it's all it does is that. You know, I put a slightly larger pulley on it, so I slowed the speed down a tiny bit. For years at Bourgeois, I just use it. Actually, I used Dana's from the '60s that he had bought when he was at Bowdoin, and he had it in his dorm room at Bowdoin. Yeah, he started building guitars in his dorm room at Bowdoin, and that first tool he bought was this Craftsman 6x9 belt disc sander, and that's what we used at Bourgeois Guitars for 4,000 guitars.
I still use a 4x36, and it's fine for like OM size. And dreadnoughts, I just have to keep it moving. You know, I just make sure that I'm constantly moving it, so that I don't like settle in on just the footage where I need
You do have to watch some of the belt manufacturers. You know, the belts will go clunk, 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 which makes it a little tougher to control. Some of the lap joints are better than others, but that's what I use, a 6x48, and it works great. And just don't use fresh 80 grit unless you have like a Cocobolo guitar that's really warped and you've done it before and you got to hog, a lot of material off.
What's interesting is that we've handled a lot of old, and you probably have too, a lot of the old Martin Rosewood from the '60s that was left over. All those sides were bent at 90,000.
Yeah.
They were all bent at 90,000 because that gave them a little bit extra wood on there. I mean, we all bent at late 78 to 82, but they bent at 90 because they knew they were going to have to get rid of the warpiness on those sides, so they gave themselves a little extra thickness to do just what I'm describing.
I could go on and on about certain things about stuff, but do you guys have any questions about like Martin bracing, Martin top thickness, voicing, any of that kind of stuff?
One more question still on that topic. Will you, after the 80 grit, will you put a finer grit on there and do it? Or do you
Not at
just
that
have it
stage,
hand?
because believe it or not, after I bind the guitar, I may go back to the belt sander again. And now I never would have done that earlier in my career, but now, I trust myself, and most of my bindings, like I said, they're either dead flush or they're in a few thousandths. And they're slightly angled, so I'm not going to thin anything. If I have a guitar where I don't trust it that much, I won't go back, I'll hand do it. But I'll go back and I'll mark up the bindings, with whatever contrasting color. If they're light bindings, I'll use dark pencil or something. And I go back to the belt sander and I'll sand until I'm getting just the tiniest little scuff mark at the bottom corner. I often do that with a lot of stuff I build these days has, side purfling in it. I use side purfling that's quite thick or tall, so it sticks out a bit. And so rather than scraping that, I'll just take it over to the belt sander on the lower bout where it's easy and just like grind it down until it's almost flush and then scrape. So a lot of my guitars go back on the belt sander after binding, but you have to just kind of touch it to save yourself a little time. And then I'm in there with a Dynabraid with a fairly hard, I have a pneumatic random orbit sander, and get it close, and then I hard block. But I've hard blocked after coming off the belt sander. I will hard block, just to make sure that side is as flat as it could possibly be. I didn't do a ton of that extra work at Bourgeois because we were cranking stuff out, but some. I mean, even there, even at a production facility, I was hard blocking areas that I thought needed a little extra tension, and in the waist, you can't get right into the waist with that. So,
John, one observation, you're talking about the Martin, and of course you're talking about the Martin aesthetic.
yeah.
And the one thing I see a lot is that probably 90% of guitars where the maker's obviously emulating the Martin aesthetic because everything else about the instrument is very much Martin.
Yeah.
So they have the bindings too wide. The bindings
Yeah.
are like, they just because they sell binding at 1/4 of an inch, you shouldn't be putting it on at 1/4 of an inch if you want
you mean
it to
like-
look like a Martin.
Yeah, so you're saying like the side view,
The height of
this
the binding.
this is a 1/4 inch.
Right,
Yeah.
yeah.
Okay. Well, on a vintage Martin, as you know, it's incredibly short. Industry standard when I started in the early '90s was like rather than 250, which is a 1/4 inch, it was around 210.
Right.
That's what Collings and Bourgeois were all doing. And then I looked at vintage Martins and I said, wow, that's more like 180 or so, or 170. Now I'm down to 150.
Right.
And if you look at some Martins, early ones, they're just above 1/8 of an inch.
Yeah.
And it looks so elegant. So yeah, good point. Bring it down. If you don't have side purfling, that height can be anywhere from, I'd say, 140 to 175 or something.
So about 5/32 to 9/64, somewhere in there. Or
If you say so.
I think that,
Yeah.
so those are work-
Yeah. Yeah, but just, I remember I got a little write-up in Acoustic Guitar Magazine early on, and it was all hyperbole. God bless them. It was a lot of hype, which was nice for sales, but they made a big stink over the fact that I had short bindings. They're like, wow, he's making Martin replicas. It's like, all I did was cut the binding height down to where it didn't look clunky. But
Yeah, it doesn't.
it's little details like that
doesn't
that
look
give a
clunky.
guitar a slightly more elegant look.
Absolutely.
Another thing I was going to talk about was bridges. Pyramid bridges. You see a lot of people doing pyramid bridges that are, you have a square here, you have a little gullet, and then you have the rest of the pyramid here, like that. And the pyramid has this point here, and then this is a cone, this section here, into this gullet. That's the hard part of getting a pyramid. It's very hard to carve that cone accurately, and there should be a little flat point right there. And the edges, let's say, so the thing looks like, if we come down here, there's the little flat point, then there's the gullet, here's your body of your bridge, and then it comes down like that. So there's your bridge. This is all cone section. There's a little flat section right there, and the side of this guy is really thin on the old ones. And it's you don't have to go, I mean, some of the old ones are really thin. You don't have to go that thin, but just if this has to be a nice cone section, and it's not that hard to do. I use this area right here, this area right here, there's a chainsaw file. I don't know what thickness it is. It might be 5/16. I can't remember. Might be 3/8.
Yeah.
It fits in there perfectly, and it's a very fine cut. It's the perfect tool to get in here, and you just like bring it back and forth, and you round it. And then I have a little plate with sandpaper on it that has a rounded edge, like that. And I wrap my sandpaper around it. I put 320 and 500 grit on there, and I pull the inside of this. Well, it's hard to describe, but what I'm doing is I'm sanding this area right in here. And I'm bringing that down because, I have you can make these by hand. I have them done on a CNC, but there's still a lot of work to be done after the CNC. And so I lay it down on this little sanding block, and this radius matches this. And it makes the whole process go really fast, and it allows you to control the thickness of this reveal. The 320 grit will take this down pretty quickly, and as it does, you'll see this corner. You've got this guy like that. As you sand it, this corner is going to drift forward, and then it doesn't match over here. So you sand that side, then you sand this side, and then you sand this thing, and you don't use little sanding sticks. Put this on a flat plate and pull it. And you can watch these lines until they all line up exactly at the corner, and that will guarantee that your reveal is exactly the same as it goes all the way around it.
I found the chisel sharpening jig to be very useful in sanding and the bevel at the end. In other words, you clamp, one of these little chisel sharpening jigs that has a little adjusting wheel and a little wheel on the bottom. If you
yes,
if you put
okay.
your blank
Oh,
in that
sure, yeah, that's
and-
great.
and
I
get
love
it
it.
Positioned consistently, mark the center and get that in the right spot.
Yeah, if you,
Off the center, it makes it very easy to sand those two bevels at the end, get them exactly
oh, that's a
right.
great way to do it.
And you
Yeah.
just go through the grits. You can, you go right up through the grits. You can basically establish your bevels initially.
Yeah.
Get them sanded right up to
Yeah.
600, and then start doing what you
Yeah. I mean,
cutting the gully and all that stuff.
the process for making these is very straightforward, for doing all this stuff. And then you just drill, if you're making them by scratch, you drill a hole that corresponds to this, in your blank. Here's your blank, and you haven't done the pyramid yet. You drill a hole here that creates the topmost part of this gullet, because this gullet is, because this is a cone, let's say here's your gullet, right here. This is angled like that. This is a cone, and there's a high spot right here, and then it comes down to this point right here. So when you drill this hole, you have to drill to the high spot, obviously. And then you just get in there with your chainsaw file and round it until you're at that low spot that you want. You just go down to as far as you want to go, bring it over to the sanding thing, and connect that low spot over here until that's a parallel reveal, leaving usually, I don't know what you leave yours at. Mine are probably about 45 thou, 50 thou, something like that.
I don't get too particular about it, but I also
Yeah,
just want to
I do it by eye.
want to make them consistent all the way around, and
Yeah.
also too with if you're building one of these, like restoring a really early Martin that has a scoop bridge, the really early ones in the 1850s
Yeah.
had a square top to the to the bridge, and the back end was slightly scooped. There's a little, that edge runs not only around the edge of the feet, it runs right along the back of the scoop and connects with the edge on the other side. You don't want to get it too, you don't want it to get.
No, I'll
edge.
get to this later. I'm not doing exactly what you're talking about.
If you do get it knife edge and you drop it, you're done.
Yeah.
You don't want to have it
Yeah.
too delicate.
This is not a very elegant drawing of this, but it's just to illustrate pyramids. This is a side view of the body of the pyramid. There's your nut slot, and here's your bridge pins going through there. The early ones, a lot of them had what we call the airfoil shape. Obviously, this would have been rounded here. The ones in the 30s, just before they went to belly bridges, were a little bit more squared off like that. But some of the earlier ones from the 20s and prior to that had more of this material back here rounded off. I do kind of half of that. Some of them can get quite thin back here if you really look at some of the early ones, but that's more of a 30s shape, and this is more of a 20s shape. And I kind of like these because, especially if your top starts to if the bridge starts to come forward just a tiny bit because your top is stretching, and you're building a really light, 028 copy or something, and you have a really thin top. If this thing tips forward a tiny bit, that airfoil shape keeps it looking cool. It doesn't, all of a sudden, the back end of your bridge doesn't look like it's lifting up, like that, which can be quite unattractive. Any other questions about tops or glues or finish or?
Grade strength on your high glue.
Oh, I don't know. I've used, and when I first got into it, everybody was like, oh, you got to go with like the 315 or whatever for this and use the weaker ones for that. Now I bought a couple of different gram strengths. I had the same 2 bags for like almost 20 years. I recently ran out, so I bought some from StuMac and some from some other guy, and I just put them together, and I can't remember what the gram strength is now. I don't think gram strength is that big a deal, honestly. I would go for a medium, whatever LMI is selling is fine, or they all come from Bjorn Industries, which is the guys making it.
What about the fish glue?
I hate fish glue. Now, that's just me. I used it one time. I don't like how it feels. I don't like how it smells. I don't like the consistency of it. I just find the way I can apply hide glue is really easy. People get really scared about using hide glue. They think they have to like have everything warm or it's going to not work. It's BS. I mean, it just, as long as the stuff isn't cold and you can get your part down within a reasonable amount of time, it's going to be fine. People are way too afraid of hide glue. And I love hide glue. I use a combination of stuff in my building, even though I'm kind of like a Martin traditional builder. I still use tight bond on certain things, and I use hide glue on a lot of things, and I use a little bit of CA here and there, and not for structural stuff, but hide glue is fun to use, and it's really not a pain. The only, you have to warm it up. I do a like a mason jar, small mason jar full, and stick it in the fridge. And if it smells good and doesn't have any discoloration or anything like that, it can last a good long time. You don't have to get all, people are like, oh, I use it once, like Frank Ford, who really knows his stuff and who I love. I think people got the wrong impression with hide glue, partly from reading his stuff. He does it because it's of the efficiency. He keeps a bunch in these little cups in the fridge, and then he microwaves them and chucks them. That's for efficiency's sake. It's not because the hide glue is no longer good. It's not, people got the wrong impression that hide glue, in the old days they used to have these factories where you'd have a hide glue pot and you'd add glue to it forever and ever. And so you'd have old glue mixed with new glue, and they had just like a some sort of bitch's brew going in there, and it was funky and it was not a good thing, structurally. But if you just pay attention to it, I use the same jar for like 2 or 3 months, and it's probably good for much longer than that. To be safe, I chuck it if I still have some hanging around.
As a hobbyist, I've shied away from it just because I don't know, it might be weeks before I get out where I'm going to use it.
It's fine. Just keep it in the refrigerator and keep an eye on it and smell it. It smells funky anyway. It's not pleasant smelling for sure. But if it doesn't show any signs of discoloration or molding on the top or anything, it's fine. I've had hide glue that got really stanky and just made a test out of it, and it worked like you wouldn't believe. Now, there are people who say
Several times, no problem.
a few times. I try not to reheat it too much. I think one thing you want to do is I don't leave it in a pot all day long. I don't have I'm not like at a violin shop or something where you just come in the morning and you plug your glue pot in and go. I have very specific needs for hide glue. They occur, with a burst of activity for a week, and then I don't really do much with it for a long time. I'm on to other parts of the process. So I'll have stuff going in where I'll have the glue pot going for a couple hours, then I put it back in the fridge, and the next day it might be out for a couple hours heating up. It's always at 145 degrees. It doesn't, if you get it too hot, they say the proteins break down above 145. Don't freak out if your glue gets a little hot. If it stays there for hours or days, it's going to break down. But if it's there for a very short period of time, it's still fine. I'm not saying boil the heck out of it. If you accidentally, I have an old glue pot that isn't a glue pot. It's a plastics melting thing that's used in some sort of industry, and it goes up to like 600 degrees. Well, one time the knob got tweaked and I boiled my glue. I mean, it wasn't just boiling, it was like vaporizing. And so that stuff obviously got thrown in the trash. But it's easy to use, and you just get I use a little warming plate that you can get at Goodwill or whatever, and I throw all my braces on it and cover them with a towel and keep it at moderate temperature. You want the sticks to feel a little warm, but not hot. If they're hot, the glue will absorb into them too quickly. So you just want to warm them. Same with a bridge or anything that you're gluing, or a fretboard or something. Just get it warm. Get the other surface warm with like a little heat gun. If you can't put your top on there or something, I just take a little heat gun and don't overdo it. Just warm it up, and I'll do the X brace, and I happen to I like the Dana Bourgeois method for gluing braces down, which is here's your X, for example, and there's a little caul that goes here and gets like most of the X. So you've got go bars can go on here really quickly. You don't have to position them very closely. And underneath that caul is hard rubber that matches the brace shape, so it spreads the clamping. So I can do that really quickly. I do the entire upper X. And I do this all the way down to the peak. I've got a peak in my X, and then I do two little ones down here. So I can do the X brace in seconds flat. I have plenty of time to get it down before the glue starts to gel. And then if you do these braces, I just take a square, piece of plywood with a little rubber on it, and a couple of go bars there. I was using a vacuum clamping system when I worked for Schoenberg and Julius Borges. We were doing hide glue. And I'd put down two braces, and then I'd have to close the vacuum rig, and I'm like, now what do I do? Now I got to go find something else to do. So I went back to the go bar deck. For hide glue, it makes a lot more sense. Then I usually do the X separately, and then I have another go bar deck over here where I'm doing something else. Then I come back on spruce. It doesn't take that long. You can take the bars off probably in 5 minutes, honestly. I don't. I leave them on there for like 40 minutes. But honestly, I bet you would have to pry a brace off of there after 5 minutes. I'm not kidding. It's on there good after no time at all. So on the second round, the first round will be that. Second round, I'll do these guys, my bridge plate, and my tone bars. And my top is almost braced completely. I could then go up here and do, here's my sound hole. I could do these guys and my upper brace and my little patch. I could do all that in one glue up. So it could be a 2 glue up system. It's very efficient.
How long do you wait before you clean up the squeeze out?
On these, I have a weird way of doing it. Nobody seems to do it this way, but I wait till they're hard. I wait overnight and then come back and I run a little chisel along it, and then I knife cut. So I'll run a chisel. Here's my brace. And I'll run a chisel along just this way and get underneath the glue squeeze out, which is right here. And then I come in from there and like drag the chisel like a knife. I just angle the corner up, and I can peel off a long section of glue squeeze out in just one thing and blow it, and off it goes. And they look so clean after that. You don't have to, and the backs are a little more problematic, rosewood in particular, because when the glue comes up, you can see it. So you have to like scuff it. The reason I do it that way is because if you use any hot water to clean up your squeeze out, or deglue goo or something like that. Do you know what deglue glue is? Yeah. It's basically a vinegar it's a vinegar in a gel solution. It will dissolve pretty much it dissolves Titebond, Tide glue, whatever. It works very well. It's a great tool to have in your toolbox. But if you do that on a rosewood back, you smear rosewood coloration into your spruce. I want my spruce to look so freaking clean. So this system means, by doing it this way, there'll be a little witness line down here on the rosewood that I'll just have to take like a really sharp pointed sanding stick and put it in there along the grain. Don't go cross grain, obviously, just to scuff it so it doesn't show up, and it makes everything look super clean. And it's very quick. And then your spruce, which is where people are really going to notice dirt, stays super clean.
Ask you, John, did you say you sanded down to your peg head and took that tongue off of your pipe? idle? When
You
you're
do-
taking that down flush?
When I'm taking this part off,
Yeah.
yeah, you just, I don't remember how I did it. You could just chisel it off and then use a sanding stick or if you're me, you probably put it on the belt sander and go, after you get it close. I'm sure I just chiseled it and then put it on the belt sander for like a second and just to and then I fit my graphite bar in there, cut at that angle, so that it was probably just a tiny bit proud and then used a hard block to clean that up.
You just run your peg head right across, and glue it up.
Yeah, sure. I just put a spacer in there so there's room for a nut, and then glue it on as you would any veneer. Yeah.
Now, are you doing steel strings and using just the graphite?
Pardon?
Are you doing a truss rod if you do steel string?
No, these are steel strings. So I'm using graphite bars in these. The reason I'm using graphite bar and all, this joint is designed to look like an 1880s, 1890s guitar. Although it's a steel string guitar, it's not a gut strung guitar. I want it to have that vibe, and I want the neck to be lightweight. So that's why I'm using the graphite, because it keeps the weight vintage. Feels like there's no truss rod in there.
Okay.
So.